Okay, so now we're going to look at 4.2 binomial distribution. So for many probability experiments, the results of each trial can be reduced to two outcomes, success and failure. This type of experiment is called a binomial experiment because there are only two options. So for example, when a basketball player attempts a free throw, he or she either makes the basket or does not make the basket. Okay, so we have a couple of properties of binomial experiments. The first one is that the experiment has a fixed number. Of trials where each trial is independent of the other trials. Okay. The second one, there are only two possible outcomes. Success and failure. Okay. The third is that the probability of success is the same for each trial. And the last one is that the random variable x counts the number of successes. Okay, so we have a couple of different variables. So notation for binomial experiments, the number of times a trial is repeated is our n, or our sample size. The probability of success in a single trial, we're going to use lowercase p. And the probability of failure, we're going to use lowercase q. And we know that lowercase q, or the probability of our failure, is 1 minus the probability of our success, so 1 minus p. And then just like what's listed in number 4, x, the random variable, represents the number of successes in n trials. So if we look at this first example, the simple example of a binomial experiment, from a standard deck of cards, you pick a card, note whether it's a club or it's not a club, and replace the card. You repeat the experiment 5 times, so n is going to equal 5. The outcomes of each trial can be classified in two categories: select a club, select another suit, and the probability of success and failure are. So we know that there are 4 suits, or 13 clubs, however you want to think about it. So there's 13 clubs out of the 52 total, or the club is 1 suit of the 4, so 0.25. Okay, Q, we're just going to do 1 minus the 0.25, which equals 0.75. The random variable x represents the number of clubs selected in the 5 trials. So the possible values of the random variable are x equals 0, because we could get 0 clubs, and then all the way up to 5. All right, so looking at this first example, determine whether each experiment is a binomial experiment. If it is, specify the values of n, p, and q, unless the possible values of the random variable x. And if it is not, explain why. So a certain surgical procedure has an 85% chance of success. The doctor performs the procedure on 8 patients. The random variable represents the number of successful surgeries. So we want to make sure that it's independent. Okay. And it is, because the second surgery isn't affected based off the first. Okay. We have our number of successes. So we're looking at a total of 8 patients. That would be our N value. It says the probability of success is 0.85. Okay, and that success is whether or not that they have a successful surgery. So it is binomial, yes or no. So our Q value is 0.15. So we can say that we do have a binomial experiment. Okay. And the key reason why is because each surgery is independent. And let's see, we also needed to list our X values. And since there were 8 surgeries, we're going to go from 0 all the way up to 8. All right, a jar consists of 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacement. The random variable represents the number of red marbles. Okay, so here it says without replacement. Since we're not replacing the marble, it becomes dependent. Okay, and since it's dependent, that means it's not a binomial experiment because the probability of success changes with each trial. Okay. All right, so now we are going to look at how to find the probability of a binomial. So in a binomial experiment, the probability of exactly X successes in N trials is, so P of X equals NCX, so the combination of X numbers from N, times P to the X power times Q to the N minus X power. Okay, so the easiest way to remember the second half, remember this is the p-value represents the number of successes. So probability of success, how many were there? Then the probability of failure, how many were failed attempts? So using the binomial probability formula, find the probability that you get exactly 2 questions correct on a 3-question multiple choice quiz. Each question has 4 possible answers and only 1 is correct. So we know our N value is 3. Our X value is 2, because we're finding the probability of exactly 2 questions correct. The value for P would be 1 and 4, or 0.25, which makes our Q value 3/4, or 0.75. Okay, so if we plug that into our formula, we have 3 combination 2 times 0.25 to the second power times 0.75 to the 3 minus 2 power, or we could just replace that with a 1. Okay. So if you plug that all in your calculator, and remember our round off rule is to 3 decimal places, we get approximately 0.141. All right, let's look at the second one. Rotator cuff surgery has a 90% chance of success. The surgery is performed on 3 patients. Find the probability of the surgery being successful in exactly 2 patients. So our probability of success is 0.90, which means our probability of failure is 0.10. It's performed on 3 patients, which means that's our N value. And again, we're looking for when X is exactly 2. So the probability of 2 successes is going to be 3 combination 2 times 0.90 to the second power times 0.10 to the 3 minus 2 power, or first power. So plug that in your calculator. And if you do that, you get approximately 0.243.